Why do you think there are living things? There is absolutely no necessity for dust to aggregate and become vital, not less, let alone think. Do we know why we have life? I guess not. But
why? Allow me to address that.
yes.
If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O, 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like anybody.
No, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. You can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the 3rd row there. So, actually that was the 2nd row. They must be related to the 2nd row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument.
Well,
somehow life is exotic.
Let me just make sure I understand what you're saying. I don't know that everybody in this room or everyone in the world would think that life is merely an aggregate of the right chemicals in the right order, all holding hands in the right way. You get your carbon, you get your oxygen, you get your nitrogen, you get your hydrogen, and you put it all in the right way, and bing, up comes a little cell, and then you get a bigger thing, and then you get a fish, and then you get a you. It may be. Is that your view? That the world is pregnant with life because all life is a chemical machine arranged in some lucky way. You don't even like the word lucky. In some...
Yeah, was the guy lucky over here?
Yeah, never mind.
Okay. I thought we got through that.
Yeah, okay, we did. Is that right? That's your view?
I'd rather say it a different way.
Okay.
I'd rather say that given the chemical fertility of carbon and the abundance of all the ingredients in the universe that is fundamental to life as we know it, I'm not given any reason to doubt that the formation of life from out of chemical soups brewing either in our solar system or across the galaxy or the cosmos itself, I'm not given reason to believe that that should be a rare phenomenon.
Your friends of life in the book are, you like liquid, because liquid just seems to slush
Life as we know it.
Life as we know it, sorry. Carbon, I guess planets with hard surfaces would be good. Something like a rock occasionally. I mean, maybe you could have.
I don't know. We just recently learned that most of the biomass of life on Earth is probably living beneath Earth's surface, in the nooks and cracks and crannies of Earth's crust, where the number of ways and places to live vastly exceeds the number of niches that exist on Earth's surface.
At least they're rocks. I mean,
what I'm saying is, to say you need a surface, I don't know that you need a surface.
I just maybe, if you're going to be in Saturn, you're just kind of dealing with a cloud. Maybe you could grow in a cloud, but at least if you have a rock or something.
Wait. Do fish care that there's a surface? No, because they're swimming through a liquid. They're swimming through a fluid. They don't care. Fish don't go down to the ground and hang out unless you're a catfish. Okay? They're swimming. So why can't there be swimming life in the atmosphere, in the gaseous atmospheres of the Jovian planets? There's nothing in principle that should prevent that any more than life swimming in the ocean is prevented just because you think we need a surface to live on.
All right, let me just ask you about because here you seem to be on the joyous side. If I ask
Buoyant was your earlier adjective.
Yes. Well, because that was too fishy for me now. Do you think that life is a fluke, obviously you think it's likely. Let me ask it this way. Do you think because of what we have all learned, say, in the last 10 or 15 years, there's Titan and some of the other, maybe Europa.
The moons
maybe
of the outer
Mars,
planets.
Maybe moons. Is your bet that there is life all over now a more promising bet to you, do you think, or about the same?
Oh, the likelihood, the prevalence of life in the galaxy, if you can quantify that somehow, I don't know how to quantify it just yet, but imagine that's a quantifiable entity. The prevalence of life that we presume to be out there, the stock in the prevalence of life has gone up in the past 10 or 15 years.
Why?
Because, for me, the best argument for upping that stock value is the following. I don't know the age of everyone in the audience, but I would bet that when you took biology class and you learned the age of the Earth 4.5 billion years ago, that's if you took biology in a school where that's taught. Okay, 4.5 billion years. And then you look at the earliest evidence for life, fossil evidence of life on Earth. Then you get about 3.5 billion years. Subtract those two numbers, get the difference between those two numbers, and that's the time clock from beginning to the first evidence for life. Okay?
So the first.
So that was about 1 billion years out of the 4.5 billion years that Earth has been here. So that's pretty quick. It happened in like the first 20% of the life of the planet.
And the first 20% was pretty rough. There was a
Wait, no, hold on. Now, since the time we all took biology, we have found fossil evidence of life farther back in time than 3.5 billion years. Yeah. It now goes back to 3.8. There's some evidence it might even reach 3.9. So we have shrunken the time available for life to have formed on this Earth. That makes it more likely. If the faster life kicks in from a pool of just random chemicals, not random, they're the chemicals of the universe, the faster that happens, the more confidence I have that life is something that would happen just given the right soup and soup starter, okay? Now, we then learned, when computers got good, better than they once were when we were in school as kids, that the early universe, the early solar system didn't just simply make the sun and the planets. There was debris all scattered in interplanetary space. And that debris slowly got vacuumed up by the gravity of the respective planets. That would not have been a pleasant occasion on the surface of those planets. Because to vacuum it up simply means you're getting slammed by the kind of asteroid that took out the dinosaurs, except you're getting that monthly. And you can calculate what the temperature of Earth's surface would have been. And it would have been higher than what would allow complex molecules to form. Because at high temperatures, you break apart molecules. So, What our computer models show is that this period of bombardment, period of heavy bombardment is the official phrasing, lasted 600 million years. So it's not fair to start the life clock at 4.5 billion years ago, because life had no chance of forming when the surface of the Earth is molten. Wait for things to cool down. When there's a chance that carbon can run its magic, then you start the clock. Now you're going from 4 billion years ago into 3.8 billion years. And you have pinched the time it takes to start life down to 200 million years, down from a billion years that was imagined just a generation ago. And that is further evidence that practically the earliest life could have formed, it did. So just because we find it hard to do in the laboratory doesn't mean nature found it hard to do as well. And the idea that it's hard for nature to do because we can't figure out how to do it yet, that itself is an inexcusable expression of human ego.
All right, let me finish the thought.